Tejas, the DevOps engineer, your host for today's session. I'm thrilled to be joined by two amazing experts. One is Rahul Vastar, our infrastructure specialist, and Namrata, our monitoring and reliability expert. Together, we'll explore the real world DevOps journey from writing code to deploying it seamlessly on the cloud. So let's see the today's agenda. So DevOps in action. We'll be discussing about DevOps in action, and the second one is version control and CI/CD fundamentals, and the third one is automation. That is like we'll speak about infrastructure as a code, and we are wrapping up with Q&A. So before we dive in, let's know the audience, like what are they up to. So we have a poll, like you can just opt it, like how familiar you are with DevOps. Yeah, like we have seen mix of blends of beginners and expert experienced pros. So just like it's a right time to start with the discussion. So all right, let's kick off this. So Rahul, please, like people are here, like they want to hear what is DevOps and then what is the difference from what separates from DevOps from traditional software development. So Rahul, it's all yours.
Yeah, I hope I'm audible and thank you, Tejas, for the introduction. So, yeah, in my views, the DevOps, right? DevOps is not just a set of tools or an automation practices. It's a fundamentally a culture shift in how we approach building, deploying, and operating software, right? So, regarding the culture, the change in culture is like prioritizing collaborations or handoffs, like automation over manual work processes and continuous feedback over isolated testing cycles. So this is what a basic uh, DevOps would be there. Yeah, this is. I think I will I will add on one more thing, like basically I would like to bring up, like in traditional days, right? uh, yeah, so there was a in in if you go back around 10 to 15 years back, like software development largely followed the waterfall model, right? So the teams would build an entire application end to end, design, develop, and test, and only after everything is completed it would finally move to the production, right? Where the operations team will take up the ownership of moving the application live, right? You can see the problem there. It's You can see the problem, like such as there is a slowness, or there is a rigid, and there is also a disconnected way of ways of working, right? Developers wrote the code and tossed it over the wall, saying that like this has to go for a production. And operations team, those are the team where taking all the code, and they were able to deploy it. But in the production, whatever the firefighting they used to do, it was all for them itself. Like they were not knowing much about the way of development, right? The collaboration was not there. That was a major one. That's where the DevOps came in, right? To bridge the gap between the development and operations. It emphasizes like like collaboration, automation, and continuous feedback, turning software delivery into a shared responsibility instead of a handoff, right? I would like to sum up, like in short, DevOps is not about tools, it's about mindset, creating an environment where development and operations work together with a common goal, delivering reliable and software faster. Yeah, this is.
So yeah, that was a wonderful explanation, Rahul. So I really like how you highlighted the shift from isolation to collaboration. So and one thing we like many people are familiar, like we are aware of one word, like one sentence saying that it is not working in my machine. So as a DevOps, how can we resolve this issue? So in a like environment consistency, can you please say about this, Rahul?
Yeah, that's a great question, Tejas. Actually, if you want to tell about, like, even I have faced it many times. It works on my machine, but it will end up in production saying there's an error or any kind of 500 of errors, right? So almost every developer has said it, like it works on my machine, but only to find that same code breaks in production. This happens because the environments between the development, staging, and production aren't consistent, or in the previous or the older HDLC processor didn't had multiple environments, right? So that's where these things occur, right? So how DevOps tackles is like it will tackle with the CI. That is a major CI/CD pipelines, right? Those are the major benefit. Okay, that will directly tackle heads on, saying that we do the continuous CI, like continuous checks of the code quality, uh, or it might be a environment variable groups issues, or those like similar to all those config files or infrastructure as a code. That also plays a major role here, because if we keep everything automated or in a infrastructure with like not much human intervention, right? So there will be a proper consistency between the environments, and that's where we introduce the multiple controlled environments like dev staging, and we have QA or beta as well. So by automating testing builds and deployments, DevOps removes human dependencies and ensures reliable, repeatable results. Yeah, this.
That was a good response for the question, Rahul. So, DevOps really eliminates the uncertainty that comes from manual configuration and mismatched environment. So, now moving forward, Rahul, could you please highlight the key benefits organizations actually see when they adopt DevOps?
Yeah, absolutely, Tejas. See, when DevOps is implemented effectively, right, it brings some tangible benefits that completely transform how teams work and deliver software. So the major benefits like collaboration, which breaks the silos between the development and operations, then the speed and agility where the native CI/CD integrations come play, right? And we have quality and continuous improvement by improving automated testing, code reviews, and monitoring. So these kind of things will allow the which will make our product very it will improve the quality of the product, which will reduce the less error prone as well. And even reliability and scalability are the major part when it comes to infrastructure as a code, because that's the place where we will try to reduce the scalability and reliability when it comes to the production environment. So yeah, these are the benefits which majorly comes when we shift into our DevOps. Yeah.
Beautifully put, Rahul. So I think that gives everyone's a clear understanding that DevOps isn't just a set of practice. It's a mindset that drives collaboration, speed, and reliability. So yeah, let's talk about the first pillar of DevOps, that is version control. But before going to that, why don't we like ask the audience like which is the workflow they are using right now? So we'll have a quick poll so that we can understand the audience. That's like many of them have chosen like feature branch and PRs. That's a great progress, which all of them are working right now. So Namrata, people still ask about why does merge conflict happens, and that beyond that, how does Git fit into DevOps culture beyond just like Git merge? Can you please explain about this, Namrata?
Yeah, can you hear me, right?
Yeah, I can hear you.
Okay, so that's a valid question, Tejas. So before moving into the question, right, let's understand the unsung hero called Git. So we all know the few commands like Git push, Git pull, Git commit, but in DevOps culture, it's much more than that. It's a collaboration hub, it's a time machine. So every automation which we have, that will start with Git event itself. It might be a Git commit or it might be a Git merge. So Git is not just a repo, it's a command center for the delivery of the software. And any CI/CD tools which will use GitHub Actions or the Jenkins. So these all listen to the Git webhook itself. So Git will determine what we need to build, where we need to deploy it. So using the something called as a branching strategy. So every commit of the Git, we can see who deployed a particular code to production, who committed this code, and we can understand using the commit message what exactly a person did it. So it is like an documentation also as well as it's important for the automation. And talking about the first question, why do merge conflicts ever happen? It will happen when we don't have the proper communications. Let's say that there is no shared rhythm between the developers. That time the merge conflicts might have happened. Our branch is there for the long time. It's not that move to a particular branch. That time merge conflicts might happen. So if a merge conflict is a symptom, then the cure is not is a Git command. It should be the collaboration between that team or between the two developers.
So yeah, and there is one more, like one question, Namrata. So why do we use different branches instead of directly committing into the main branch?
Yeah, so we need to use the something called as a branching strategy. So branching strategy is like a backbone of how teams deliver the software. So Git branching models will define how we need to develop or how we need to deploy or when the code moves to the between the environments. There will be a particular branch which is dedicated for the testing, and there will be a particular branch which is dedicated for the live environment. So instead of committing everything to one main branch where it might break the production or some chaos will happen, branches will let teams work independently and safely without causing any issues with the production. So when it comes to the branching strategy, like different teams will use different models. They based on their release process or their automation maturity and all. So let's see few of them. So there is a one called Git flow. So in Git flow, what happens is like it's like a structured release, and multiple environment will be there, and there will be a long-lived branches. There will be one master branch, one develop branch, and there will be particular feature branch, and one release branch will be there. So they using those branches, all the release will happen. So it is for when we have to do control deployments, version-wide releases. That time we can use this model. And if I can say example, we will merge a feature branch to the develop branch, and from there we'll decide one release, and from there we will merge it to master branch. This is what Git flow does. Then one more we have is GitHub flow. This is like for the shorter teams, like where there is no much features are going on a small project. So that time we can have two branches. One is the main branch, and there will be a sub branch. We can create a feature branch. From that feature branch, we can merge it to main branch. There will be no intermediate branches between them. And one, the new or modern technology is trunk based development. So like everyone are aware of this. So here, like we will be having one main trunk, and we will be creating branches from there, and we will do the testing, and we will merge it to main branch itself, like after all the intermediate testing is done. So here, like after merging, we will delete that branches. So we will be having that short-lived branches, and this is useful when we want to do the continuous deployment. So every time the code will be there in the production, whenever something is developed, it will be there in the production. So every it's the continuous deployment.
Oh,
So
yes.
yeah, so there will be some best practices we can do, use this like a version control. Like one is like writing the meaningful commitment stages, and so that everyone can understand what we did, and having the proper branching name so that we will get to know what this feature is about, and also the keeping the repository clean and organized, like maintaining the proper folder structure so that we will having one standardized code and all.
So yes, Namrata, thank you for responding to the question. So, but here there is one more question. But here's something to think about. Why do we use pull request instead of just running get merge commands? So, and this is what many people are been thinking about. And can you please take up this question?
Yeah, so pull requests are like a cultural handshake in DevOps. So when we talk about the pull request, it's not about merging, just merging the code. It is like a structured conversation about the quality. So we will be having one CI checks where multiple test will be running or multiple checks will happen. Also, this is useful when we have to do the PR review. Like there will be a multiple developers will come and they will check the PRs, and they will give their feedback there. So we can improve our coding or our style of coding. And if there are, if they see any security issues there, they can suggest so that we can build a really good product. And also it is like a documentation, so we will understand when we merged it, what got merged. So also we can add here the policies, like we can maintain a standard policy, like this pull request should have been reviewed by these many people and this should pass these many checklists, then only it should move to the production. Without that it should not move. So we can have that in the software, we can have that secure and the stable product using the pull request.
Hi, Namrata. So here we have one question that is raised from Nishan Narayan. So he is asking about can you please help me in understanding the word Git? Can you please describe what is Git?
So, Git is like a command tool, which I said, right? We will be having the different commands which will help us to commit the code. Also, will help us to collaborate between each others. Let's say that we have to push it to, it's there in our local repository, and you have to push it to a remote repository. That time we can use it to doing the git. We don't want to keep anything in the local side, so we can push it to remote, and we can have like we can move from there to productions.
So well said, Namrata. Git isn't just a developer's tool; it's a DNA of DevOps workflow. It's more than a just version control, and it's a backbone of every CI/CD pipelines. Without clean branching, proper commits, and versioning discipline, automation simply can't happen. So yeah, like that's a very good insight about Git and version control. So it's time to know about the CI/CD. Can you please discuss about CI/CD, Namrata?
Yeah, so CI/CD is the automation engine. So that will connect the development and the operations. So every line of code, once it is pushed, one automation journey will become, journey will start. So it will start from the building the product, then the testing will start, then we'll do the packaging and we'll deploy it. So here the goal is isn't just a speed, it's a consistency and it's a reliability. So here it also develop the trust because it will be the same process and every time every branch same things will run. And when we talk about the CI/CD, we have continuous integration. So continuous integration is like how the developers integrate the code changes frequently into one shared repository, and when they push, build will start and the testing will happen. So this will help us to catch the issues earlier and keep our code base stable and to avoid the old drama like it worked on my machine and it's not working in the environment. And there is one more like continuous deployment. So continuous deployment is like once all these built or the testing parts without any manual intervention, we are moving everything to production. So it will happen continuously. So we can maintain this using something called as feature flags so that nothing will break, nothing will impact the users. And one more we have is like continuous delivery. Here, when the build will happen after the test, before we will move the things to staging environment. But there will be one manual intervention will be there, and after that only we will move into the production. It might be a review or it might be some downtime. After that, in that downtime only we will move the things to production so that it won't impact any users.
So yeah, Namrata, we had a question like why CI/CD pipelines have many stages instead of just big deploy button?
So, well, each stage in this CI/CD pipeline exists to catch the problems as early as possible, as I said before. So, like we can think like airport security, like we don't check everything in the one place. There will be a multiple checkpoints. Same in the CI/CD pipeline, there will be a multiple checkpoint to check each thing. Like let's say that we can check the security of the application based on the code level also and based on the application level also. Also, we will write the test cases to make sure that nothing which we developed previously is not breaking, or whatever we developed it is there as the which we discussed, how the team discussed, they know like that only we developed. And once after all these checklists, all these stages, we will be doing the deployment so that we are following the same let's say the user stories and all, we can understand in the test cases itself.
Yes, Namrata, like that was a great explanation. Now, can you please list the different pipeline tools?
So there are few pipeline tools are there as you can see here. So there are the one pretty popular one is Jenkins, and we are using the GitLab CI/CD and Azure DevOps, but we used to do the Bitbucket pipelines also. And one more is Circle CI, and in the GitHub we are using the GitHub Actions.
So yeah, thank you for the very insight about the pipeline tools. So thank you, Namrata. So let's shift the gears and talk about something every DevOps engineers loves about automation. Rahul, like we have heard about word automation so many times in DevOps, but why exactly is automation so critical today? Can you please say about that automation?
Yeah, absolutely, Tejas. So automation is the backbone of the DevOps. Without it, everything would still depend on manual effort, or like from like building code to deploying it. And even the problem with manual work is simple. It's slow, inconsistent, and prone to errors, right? So imagine you have to create a servers, configure databases, and even set up networking infrastructure, networking by clicking through hundreds of console options every single time. Okay, that's what team used to do before. Now, okay, let's take this instance as a simpler one. Now, if you want to complicate this, right, you can imagine like the same task you want to do for 100 environments, or if you want to do for 100 different resources, right? It will be like you need to sit and work on the same part most of like it will require the most of your duration, right? Uh, so that's what, like, automation removes all the repetitions, like it brings speed, consistency, and reliability to every step from code build to the infrastructure provisioning. Okay, so and that's all, like the initial commits, like even if you add it like from the Git or any the DevOps concept, whichever you bring, right? So automation plays a major role here. So yeah, Tejas.
I think there are few questions in the Q&A board. Yes, Randit, okay. Like, can you please take it up?
Yeah. So when there is a question from Nidarshan, like how do we manage this when we have an external team or a developer or work on client Git environments? So as Namrata has explained, like we have different strategies of Git strategies. So if we are aligned with one standard strategy, we are both aligned with external or any of the clients. Like if you are following one branching strategy, it has certain guidelines, certain structure to it. So these allow us to have a collaboration with whether it is an external, whether it is the other developers, like many other things. It's like we are traveling in the same boat, right? So that if you all traveling the same boat, like we can go faster, we can row faster, right? If you start rowing at the same time, we can able to reach it faster. The same way it is, like if you're following a one standards, so it has its own guidelines that can able to collaborate very effectively. And we have few more questions, like why do we merge pull request to a single branch like main or master, or how is that different from using rebase? So there are two strategies when we are merging from one branch to another branch. Like one is like merge strategy, another one is rebase strategies. So rebase strategy, what it does is, like instead of merging, like consider there are 3 to 4 developers are working together. They are working differently, different features, different features. So rebase means like you need to get pull from everything, each and everyone, and then you need to rebase it, so that all the codes which from the different developers will be taken into one single branch, and then you will be merging it. When it comes to auto merging it, merge strategy is like, even though don't have to pull, the strategy will help to merge between two branches, see the each and every lines, what are the commits, uh, what are, if any conflicts between that lines is there. So if there is no conflicts, as it can able to merge effectively. There is one more action is not required to take a pull from that respective developers, right? So that is the major difference when it comes to merge strategy, merging strategies, and then the rebase. We have one more question from Pavitra, telling that how do you balance speed and stability in a CI/CD process when frequent developments are required? So that is the reason, like when we have frequent development comes, will be multiple branchings. That's the thing. Like one of the strategy trunk-based developments. Trunk-based developments will be help us to do frequent development with frequent deployment together. So it works as a frequent. We can create a release candidate from a short, like small features, or a very if you're getting feature delivered very faster. So that strategy will not wait for everything to come. So with the help of feature flags, with the trunk based development, we can able to deliver the code to the production without any waiting. So that when we have when we have a proper testing done, different checks we done, so we can just enable the feature flag to make it available to the all the users. So these strategies in trunk based with the feature flag strategy will help us to speed up the process, and it gives space for us to testing even the code is there in the production. And one more thing, one more question. Is it possible to undo a commit? The commit you can't able to undo. You can able to tag it like before you committing on stagging it out. So commit is like is a footprint. It's already been made. So you can able to go backwards to the commits. You can't because like commits work has a head of it. So the currently it takes like the latest commit is a head. You can go back to the commits. You can't able to delete the commit. It has been footprint has been already been made. So right, you can able to go back to the commit and start developing from there. So that the link between the head and the latest will be removed. So yeah, that's all from Tejas. You can continue.
Uh, Thank you, Ranjit, for picking up the questions. So yeah, like there's one more like everyone used to ask like why do we the why do where do we use automation in real life? Rahul, can you please explain this in the actual organizations or where do we use this automation? Can you please take it up?
Yeah, Tejas, like the automation, right? We can't create automation for all the things. Like if I want to create a simple example, like if I my daily task is like I am creating any of the meeting in our calendar, like it's a simple example where uh, I can't automate saying that I have to come daily and I have to create an meeting, right? Because each meeting I might change the agendas, right? So that's the reason there are some limitations for the automation. You have to plan. You can't just simply create an automation for everything. Taking an example, if you are creating if you are like if you want to create some scripts, right? If you want to create a scripts which has to run in your pipeline, or if there is a challenge which you are doing every day, a same similar task, a 10 set of tasks, a 10 set of steps of a task, you are doing it daily, right? That is a place where you can make it automated. You can go for a scripting, or you can go for any automation language like Python or JavaScript or anything you can do. Okay, so when it comes to DevOps, right, we have an infrastructure as a code and other deployment script, right, that we use it in our CI/CDs. So that we create it when it is most used. I won't be creating any simpler scripts for the task which I do it in once in a month, right? So if you are doing a similar task out of 50 for within 15 minutes, right? Within 15 minutes, if you are creating a task, and I don't think that requires major automation scripts, okay, or to make it automated. At the end, like automation isn't just convenience; it's what enables scaling and continuous delivery in modern systems. I hope I answered.
Yeah, Rahul, I like the perspective that you told. So now coming up to infrastructure, people often mention infrastructure as a code. How does it fit into automation? Can you please say about that?
Yeah, like as I mentioned, right, majorly we work on infrastructure as a code, which has helped us to resolve most of our old SDLCs problems, right? Like infrastructure is where automation really shines actually. Like instead of logging into AWS or Azure and manually setting up resources, we simply define the entire infrastructure as like we simply define all the resources in the infrastructure as a code. Okay, those code are nothing but how we have our JavaScript. Right? The same way we have different types of tools. So the tools are like I have mentioned like Terraform, CloudFormation, or Azure Resource Management Templates, or Ansible, which is a configuration tool. So these are all the popular tools which we use. And for a simpler Terraform example, right, I would like to bring like I think I have already shared where you can go through the code. Like it's simple, very actually simple. There is a resource which I am creating, like EC2 instances I am creating. You can see if I run that one time, right, it will by default it will create three instances. I mean, three EC2 instances it will create, right? You can see the automation, right? I don't need to configure much. Everything is already prepared. Okay. So if I give the variable as 100 times, obviously it will create 100 EC2 for me, right? So this is the magic of automation. Uh, no mistakes, and the same code can recreate identical environments in anywhere or any AWS accounts, right? So yeah, Tejas. So this is what the infrastructure like in a foundational way.
Beautifully put, Rahul. So automation isn't just a tool set; it's a mindset that powers the whole DevOps ecosystem, right?
Yeah, Tejas. Yeah, exactly. Like when it comes to code from code to cloud, right? So as you mentioned, like the complete completion of automation is each code changes initiates automated build, test, and deployment pipelines, right? So like that's how it is. Just like yeah, I think I can sum up with that same.
Rahul. So that was amazing. So before we moving to Q&A, could you please summarize the your key points for everyone watching out here?
Yeah. So to summarize, the key takeaways, like we started with the complete like foundational level of DevOps, like how actual DevOps we can define, because there are multiple different definition for DevOps as well. So starting from DevOps, then we moved to the version control, where we learned about the Git and Git workflows, and how it is helping in the collaboration, right? And how the CI/CD acceleration accelerates delivery. Like because since the CI/CD enables the speed, and it will help with agility, right? So that's what the second takeaway which we have grabbed. Then we also have automation extends beyond code, which is just recently I have finished it off, right? Where we go from infrastructure testing and monitoring automation, create efficiency, right? And also the majorly branching strategies, which we had different branching strategies, which helps to decide on what environment or how the ways of working we use. So yeah, they just like these are all the key takeaways or like summary of our whole session.
Yes, Rahul. So I think a lot of our folks are watching right now, having questions popping out in their mind, and I think it's the right time to move to Q&A session. So, you can, if whoever has doubts, they can please post the questions in Q&A. Please be free to ask the questions.
Um, yeah, we have a question. How would you integrate AI and predictive analytics into DevOps ecosystem to achieve self-healing and automated anomaly resolution while still maintaining human control and accountability? As like when we talk about AI in terms of DevOps ecosystem, right? So there are many tools come up in the recently, like we have Amazon Q, right? Amazon Q, like or else any like for Terraforms and all, right? So these ecosystem when it comes to automating or infrastructure creations, So AWS queue will give you, it has three different interface. One with like interactive, like you can able to use it with interactive in the AWS console itself, right? And then we have it one more in the Amazon queue. We have chat system, right? And then we have CLI. So any of this one, so with just creating like one of the script Rahul Wastra has shared, like creating on three EC2 instances. Instead of you writing the code, you just mention it. You just have to use it, Amazon queue, and just give a prompt that I need to create a three EC2 instance with this certain images. So these tools will go to AWS, and then AWS and start creating it. All the cloud providers right now we started to provide an MCPs, right? MCPs to make action to that cloud, right? So basically, using integrate with the AI to create manage the tools, right? So we can able to you can able to automate some of the things, right? We can able to create some of the resources when you wanted to have repetitive things, so that you can use any of the LLMs to create terraform scripts to create any certain resources. We can able to manage it through them. So that are the two. There are like something, if it comes to like, there are some recently there AWS and Azure has been released some of the tools when it comes to monitoring also. So these monitoring also, like there is an investigate. AI investigate is integrated with the AWS CloudWatch, so that what is happening inside the resources, if any anomalies are there, any problems are there, so these can be identified with the already integrated AI LLMs that are already been provided by the AWS, right? So, while still maintain like control, as it like the AI will not automatically pick it up few of the resources, because it is directly integrated with the end users, right? Directly with it in interacted with end users. They always keep it human in the loop, saying that, is it really, there is a chat system that can able to take it to action. It will ask question if it any serious changes you are making it, or any changes if you are making it, right? So this will keep the human in the loop, and then make it accountable for that action. And also any changes which has been made, like you can able to see it in the AWS consoles, using the what who made action, what is action you have made, where it is been made, like you will get the logs out of it. So we have another question: how does Git distributed nature practically benefit a team in day-to-day work? So when it Git is a distributed, like how we tell it is distributed, we have a remote servers. Like for an example, we have a providers, distributed providers, Git distributed providers like GitHub, Bitbucket, Azure DevOps. So even though you can able to manage a Git locally in your system, so that will be there in your local systems. So if you wanted to distribute across multiple team members and all, that is the place we use all these providers, Git providers, like Git distribution providers like Azure DevOps and all. Basically, the same set of Git will be stored in the AWS in the Git providers, so that you can able to clone the repository. You can able to take a copy from the remote repository and store it in your local, and make certain activities, and then again you will push it back. So, and again, when it comes to collaborations, they use it pull request mechanisms, so that it will make it easy to uh, collaborate with multiple developers, and make certain actions. So that is how it makes benefit, so that makes collaboration very easily. Before that, we used to copy the code from one, like we used to give a zip file, and then we'll give it to another person to continue with it. So that again, there are so much activity involved. It like if the same file is got changed, other things. So when it comes to distributor management, it will manage with the strategies, Git strategies to handle it. So another question: is AI improving how we use Git? If so, in what ways? Uh, AI, AI will also have like Basically, how AI is like if we able to manage some certain workflows like using some of the rules cursor, we have cursor rules, and then we can able to manage it and all. So whenever we can give it that whenever new feature is being created, we can able to automate in such a way that create a new branch, create a pull request when it is completed, when we are ready to create a pull request. So we can do certain activities with the using AI instead of you creating manually and doing it whatever. We can able to set the rules to how it can able to, since it is an action made by it is in, as I told, it is commands. So all AI now the AI tools can make a command, so that using they can able to run a command to create a branches, to create a PS, to push the commits, right? So we can able to use it. We can AI can improvise over there with the use of rules and regulation, because like AI does not know which strategy we are using it. If you set the rules and then this is the strategy we are using it, how to manage it, so it can able to take it over, right? So while most companies implement few DevOps tool chain and call they have modern SDLC practice, how it is different at our companies? So how it is different is that thing, but there are CI/CD can be expressed in different ways, right? We use something called as GitOps. So there are other companies, they will be manually deploying it, even though they have templates. There will be they'll not use Git pipelines to deploy it. They will be having a certain task that they will do it manually and all. So we use strategy called as GitOps. This GitOps will in this one, we there is no dependency with any of the engineer, right? Any of the certain engineer, like some deployments, if they make it, some of the state files, if you go with that approach, some of the state files will be stored that one, if they don't have access, so again it will become a problem. So that we will give full power to a CI/CD pipelines that uses GitOps techniques. So whenever any hooks triggered through the to the gigs Git, right? For an example, push, pull, or anything, we can able to trigger a pipeline. Using that, we can able to deploy it without any manual interactions. We just have to based on the Git triggers, we can able to manage the deployments. That is what makes difference. And because we are reducing the conflicts or a dependency with the engineer or anything, so we'll give control over to the system, right? Then we have one more question. As a developer, if I want to switch to DevOps role, what course do you suggest for a starter? Uh, as to the DevOps, I will recommend is about, we use Git regularly and all. There are in-depth concepts about Git, right? So one is about Git. Another some of the tools we need to know about the Linux system and its networking concepts. So these are the basic things we need to learn, like Linux, all about Linux, how not only basic commands, like we need to understand the many are there. Like for an example, Nginx for the for routing purposes, like reverse proxy, right? So there are to navigate to the different navigate the any request coming to that, it is to navigate to the different process, right? So that we network capabilities, like how we can able to secure with the networking, right? So and one is like, since here like we use GitOps as a technique for the most of the things, like we use terraforms, cloud formations, or if we are almost trying to do Azures also, there also we are already started with a few of the POCs regarding Azures also. So it's not we are this DevOps does not rely on one cloud, right? So it is, if you know the basics regarding the Linux shell commands, networking, we can able to do it in any of the cloud, right? Even the this Terraform is again one of the coding, right? Infrastructure as a coding. So this will allow us to do multiple we can choose the cloud, and then we can able to write code based on it. So basically, I recommend to go to study regarding the Git, Linux, networking, and uh, and about some of the recent CI/CD techniques with IaC as a code and code. Yeah, how do you balance project-specific DevOps practices with the standardizing process-driven approaches? So project when it comes to project driven, like it's all about this depends on the how we are managing releases, right? So currently we are following a trunk based development, since it is like some of the products are MVP and some of the things are like not are live, right, or already in the live, and people are using it. So when it comes to trunk based development and the other things, it can make us to release it faster. But few of the situation when the clients or we don't want to release it very often, right? So very often in that case we need to go with a different flow, Git flow strategies or Git flow strategy at all. Like we can't able to it's all basically how release management you are doing it. If you want the features very, very often, then we want to follow one approach. If you want to release it, like if you want to release it with proper testing, we don't have to move the code until we proper testing, and then we don't have to take a risk. Then we need to follow one more approach. So basically, based on the state of the project and based on the release management we are doing for the project, so we can able to change it appropriately on that one, right? So yeah, I hope I answered the question. So which DevOps metrics best support agile goals like faster iterations and continuous delivery? I just want to bring up like DevOps came because of agile. So because of agile in nature in development, right? So which metrics will help agility? Agility wants to look for the continuous value delivery, right? So how deployment frequency is the one of the thing we have deployment frequency. So we have something called as DORA metrics. DORA metrics. So this metrics is meant for the DevOps culture. So in the DORA metrics, you can able to there are many. Basically, there are four different metrics. One is like deployment frequency, that tells like how frequent the deployments is happening. Change failure rate, so that how fast how many bugs has been identified, and then after that deployment, since we have DevOps included, we have certain checks we do it, how many of them moved out of it, right? So that is one thing. And then we have mean time to resolve, so that how fast we can able to deliver, like agility requires fast, and these things mean time to resolve will give that how fast we are releasing that bug, releasing the one more release candidate that fixes that bug. So basically these DORA metrics will help us in the agile goals to meet it. Why are we not using Ansible? There are any compatibility issues. So, like Ansibles, yes, we can able to use Ansibles and other things. Like Ansibles has one more this thing about managing the state files, right? Managing the configuration files. So there are different approaches. We see the trend that is going on. Like Terraform has been used many very often, and then since it's a Terraform is open source and other things like, and then we do most of AWS, and then recently we are just looking into Azure and all, right? So of course, if we compatibility issue, we don't see as such, since we are in AWS, we are only focusing on cloud formation. Recently, to make it consistency and all, in last 1 year, we changed it into Terraforms. So Ansible also we can go for the Ansibles. Currently, Terraform does it everything whatever we wanted it. So currently, we are not going for that, right? So yeah, so. Thank you, everyone. Thank you so much for all your questions. Like, I hope I answered all your questions. And thank you for participating here. I will, yeah, Nisha, Tejas, you can.
So that was a fantastic discussion, and that was a very good questions by all our audience. I would really appreciate to all of them who have been actively participating in this webinar. So, and I would like to thank the people like who has been continuously asking for the questions. That was really great. And I would like to thank Rahul and Namrata and Ranjit for giving a very good, valuable insight in this. So yeah, that was a great participation. And we hope today's session was having a clear understanding and how automation, infrastructure as a code, like how it works in the DevOps journey. So thank you everyone for participating in this webinar. So yeah, thank you.